There are silences in the world that feel intentional, not the silence of an empty room or a quiet forest, but the kind of silence that presses against the mind, that suggests something is being withheld. Antarctica holds that kind of silence. It is a continent where sound itself seems reluctant to exist, where the wind carves through valleys no human has named, and where the ice stretches so far that even satellites struggle to capture its edges in a single frame. Before we begin this journey into the unknown, I invite you to settle in wherever you are. Let the day fall away. Let your thoughts slow. And if you feel moved to share where you're listening from, know that you're part of a quiet community exploring these mysteries together. The images you might see are simply guides, echoes, to help your imagination wander through the landscape we're about to explore. Antarctica was not always a mystery. For most of human history, it didn't exist at all, not in maps, not in stories, not even in myth. The ancient world knew nothing of it. Medieval scholars never mentioned it. It was simply absent, a blank space at the bottom of the world that no one bothered to imagine. And then slowly it began to appear. First, as a theory, a mathematical necessity to balance the weight of northern continents. Then as a rumor among sailors who ventured too far south and returned with tales of ice mountains rising from the sea. Finally, in 1820, as a confirmed landmass when expeditions first glimpsed its shores through fog and storm. But even after its discovery, Antarctica remained strange. It refused to behave like other continents. It offered no harbors, no resources, no land suitable for settlement. It killed explorers who tried to cross it. It destroyed ships trapped in its coastal ice. It seemed designed not to be known, as if the planet had reserved one final place where humanity could not easily reach, a sanctuary for secrets that needed to remain hidden. And then, in the early 21st century, something appeared in satellite images that should not have been there. Something that looked deliberate. Something that resembled structures humanity had built in deserts, jungles, and floodplains thousands of years ago. Triangular shapes rising from the snow with edges too clean, angles too precise, and shadows too symmetrical to dismiss as mere geological accidents. The scientific community responded quickly. These were nunataks, they said, mountain peaks sculpted by glacial erosion. Natural formations created by the same processes that shaped mountains everywhere on Earth. Nothing unusual, nothing to investigate further. But the explanations felt rehearsed, almost defensive, as though the shapes themselves had violated an unspoken rule by appearing in the first place, because Antarctica is not supposed to hold human history. It is supposed to be untouched, pristine and empty. A place where the past does not exist because life itself barely exists, so when shapes appear that look unmistakably intentional, when geometric forms emerge from a landscape that should contain only chaos and wind-carved stone, something fundamental begins to shift. Not in the ice, but in the story we tell ourselves about where we came from and how long we've been here. This is not a story about proving anything. It is a story about questioning, about looking at evidence that sits uncomfortably between the natural and the impossible, about considering what it would mean if the world we think we know is actually a world we've forgotten. The Black Pyramids of Antarctica are not the answer, they are the question. And the question is simple, terrifying, and impossible to ignore. What if everything we've been taught about human history is incomplete? What if civilizations rose and fell long before our oldest records begin? What if the ice covering Antarctica is not just frozen water but frozen time, preserving a chapter of the past that was never meant to be read again? The images first appeared on public forums in 2016, though the satellite data they came from had existed for years. Someone with too much time and too much curiosity had been scanning Google Earth's coverage of Antarctica, moving slowly across endless white terrain, looking for nothing in particular. And then they found something. 3 triangular formations arranged in the Ellsworth Mountain Range. Not rough peaks, not jagged outcrops, triangles. Clean, dark, symmetrical triangles that looked as though they had been placed rather than formed. The images were low resolution, grainy, distorted by atmosphere and snow glare. But the shapes were undeniable. Within hours, the images spread. Reddit threads multiplied. YouTube videos appeared. Comment sections filled with arguments between those who saw evidence of something extraordinary and those who saw only mountains being misinterpreted by overactive imaginations. But what made the debate unusual was how persistent it became. Most internet mysteries burn bright and fade quickly. This one didn't fade, it lingered, it grew. And the more people examined the images, the less certain they became about what they were looking at. The formations were not identical, but they shared characteristics that seemed too consistent for randomness. Smooth slopes rising at similar angles, shadows falling in ways that suggested flat faces rather than irregular terrain, proportions that resembled architectural intent rather than geological accident. One of the structures appeared to have 3 visible sides meeting at a sharp apex. Another seemed almost perfectly triangular when viewed from above. The third sat at a distance that, according to some observers, aligned with the other 2 in a pattern that could not be accidental. Scientists entered the conversation immediately, and their explanations were confident. Pyramidal peaks are common in glaciated landscapes, they said. When glaciers erode a mountain from multiple sides, they create sharp ridges that converge at a point. The Matterhorn in the Alps is the most famous example. Antarctica contains hundreds of similar formations. The shapes are natural, explainable, and entirely consistent with known geological processes. But the explanations did not settle the matter. Instead, they revealed something more interesting, a disagreement within the scientific community itself. Not all geologists were comfortable dismissing the structures so quickly. Some admitted the formations appeared unusually crisp. Others noted that the angles seemed more uniform than typical glacial peaks. A few pointed out that the alignment of the structures, while not proof of anything, was at least intriguing. The debate exposed a tension that runs through all scientific inquiry, the tension between what is probable and what is possible. The probable explanation is that the pyramids are mountains. The possible explanation is that they are something else. And because Antarctica is so remote, so dangerous, and so inaccessible, no one could offer anything more than interpretations of pixels captured from hundreds of miles above the surface. What made the discovery even more frustrating was the quality of the evidence itself. Satellite imagery is always ambiguous. Angles distort, shadows exaggerate, resolution limits detail. What looks sharp from orbit might be jagged on the ground. What appears symmetrical might be an artifact of the way light interacts with snow. The images showed enough to provoke questions, but not enough to answer them. And so the structures remained in a state of suspension, not confirmed, not dismissed, not investigated, not forgotten. They became a kind of optical puzzle, a Rorschach test for worldviews. Those who trusted mainstream geology saw mountains, those who questioned mainstream narratives saw structures, and those in the middle saw something unsettling, a shape that refused to fit comfortably into either category. The most troubling aspect of the discovery was not the shapes themselves, but the reaction to them. The speed with which explanations appeared, the reluctance to consider alternatives, the absence of any serious proposal to investigate further. It was as though the scientific community had decided in advance what the structures must be, and any suggestion to the contrary was treated not as a hypothesis worth testing, but as a threat to credibility. This reaction revealed something important. Science, for all its commitment to exploration and discovery, operates within boundaries, not the boundaries of nature, but the boundaries of acceptability. There are questions that can be asked safely and questions that cannot. There are conclusions that can be drawn without controversy and conclusions that invite ridicule. The Black Pyramids of Antarctica fell into the second category. They were too strange, too disruptive, too laden with implications that would require rewriting textbooks and reconsidering timelines. So the discovery changed nothing. The images remain publicly available. The debate continues in quiet corners of the internet, but no expedition has been launched, no ground team has been sent, no direct examination has been attempted. The pyramids sit exactly where they were found, visible from space, unreachable from the ground, and suspended in the uncomfortable space between mystery and dismissal. What if the reluctance to investigate is not about evidence, but about consequences? What if the real reason no one is looking closely at the Black Pyramids is that finding something artificial would be too disruptive to accept? What if the discovery that changed nothing is waiting to become the discovery that changes everything? When confronted with the unexplained, geology offers comfort. It provides frameworks, processes, and terminology that make the strange feel familiar. It reminds us that the Earth has been shaping itself for billions of years, and that patterns we think of as remarkable are often just the predictable outcomes of natural forces repeated over immense timescales. The geological explanation for Antarctica's Black Pyramids is straightforward. They are pyramidal peaks, or nunataks, formed through a process called glacial erosion. When glaciers flow around a mountain from multiple directions, they carve away softer rock, leaving behind sharp ridges that converge at a summit. Over time, the mountain takes on a pyramidal shape, not because of design, but because of the mechanics of ice and stone. This explanation is not invented to dismiss the mystery. It is based on observable processes that occur in mountain ranges around the world. The Matterhorn, Mount Assiniboine in Canada, and countless peaks in the Himalayas all exhibit pyramidal forms created by glacial action. The process is well understood, well documented, and entirely natural. So why does the explanation feel insufficient? Part of the problem is that nature rarely produces perfection. Glacial erosion creates sharp peaks, but those peaks are seldom symmetrical. They exhibit irregularities, asymmetries, and variations that reflect the chaotic nature of ice movement and rock composition. Yet the Antarctic formations appear remarkably clean, their slopes seem smooth, their angles seem consistent, their proportions seem deliberate. Even geologists who defend the natural origin of the structures admit privately that something about them feels unusual. Not impossible, but unusual. The kind of unusual that makes you look twice, that lingers in the mind, that refuses to resolve completely. Another issue is the surrounding terrain. If glacial erosion is responsible for these pyramidal forms, one would expect to see similar shapes throughout the region, but the Black Pyramids stand out. They appear isolated in a landscape that does not show the same degree of sculpting. The ice around them has carved other features, valleys, ridges, and slopes, but none with the same geometric precision. This raises a question. If the conditions were right to create these perfect pyramids, why didn't they create more? There is also the matter of preservation. Glaciers are not gentle. They grind rock into powder. They shatter stone through freeze-thaw cycles. They reshape landscapes over millions of years. Yet the Antarctic pyramids appear sharp, as though they were carved recently or protected from the erosive forces that should have dulled their edges long ago. The ice itself may provide part of the answer. Once a mountain is covered by ice, it is shielded from further erosion. The forces that would normally wear down a peak are stopped. The structure is frozen in time, preserved exactly as it was when the ice sheet advanced. This could explain why the pyramids appear so pristine. They may have been sealed beneath the ice for millions of years, emerging only recently as the ice sheet shifted. But this explanation introduces another problem. If the pyramids were carved by glaciers and then covered by ice, they should resemble other glacial peaks, yet they don't. They look sharper, cleaner, more symmetrical. They look less like natural formations, and more like something that was designed to withstand the conditions that should have destroyed them. This is where the geological explanation begins to feel less like an answer and more like a framework struggling to accommodate something it wasn't built to explain. Geology can account for pyramidal peaks. It can explain how ice carves stone. It can describe preservation through burial, but it cannot fully explain why these particular formations appear so much more precise than others in the same region. Some researchers suggest that the precision is an illusion created by snow cover. Snow smooths irregularities, it hides rough edges, it creates the appearance of symmetry where none exists. From a distance, any mountain might look perfect if the conditions are right. This is a reasonable hypothesis, but it raises the opposite concern. If snow can hide imperfections, it can also hide details. What if the structures are not perfectly smooth? What if they contain features that the snow conceals, features that would resolve the mystery if they could be seen? The limitation works both ways. Snow might make natural formations look artificial, but it might also make artificial formations look natural. The deeper one examines the geological explanation, the more it becomes clear that it is not definitive. It is provisional. It accounts for some observations, but not all. It explains the general shape, but not the specific details. It offers a framework, but not certainty. And perhaps that is the most honest place for the explanation to rest. Geology does not prove the pyramids are natural. It suggests they could be. It provides a mechanism by which such shapes might form. But it does not eliminate the possibility that something else is responsible. The question is not whether geology can create pyramidal forms. It can. The question is whether the forms we see in Antarctica are the result of glacial processes or something older, something intentional, something preserved beneath the ice until satellites finally revealed its outline to a world unprepared to interpret what it was seeing. Antarctica is not simply remote. It is hostile in ways that defy preparation. Temperatures plunge to levels where exposed skin freezes in seconds. Winds accelerate without warning, turning visibility to zero and sound to chaos. The terrain shifts beneath the ice, creating crevasses deep enough to swallow entire research stations. Even the most advanced technology struggles to function. Batteries die, instruments malfunction, communication systems fail. This is not a place designed for human presence. It is a place that actively repels it. Yet beneath that hostility lies something even more formidable: secrecy. Antarctica does not just resist exploration, it conceals. It hides entire mountain ranges beneath ice sheets kilometers thick. It buries lakes the size of countries. It covers landscapes that have not been seen by sunlight in millions of years. The continent does not merely exist in isolation, it exists in darkness. More than 98% of Antarctica is covered by ice. That ice sheet contains about 90% of the world's fresh water. In some regions, it reaches depths of nearly 5 kilometers. To put that in perspective, the ice above parts of Antarctica is taller than the highest mountains in most countries. It is a weight so immense that it compresses the land beneath it, pushing the bedrock down below sea level. This means that much of what we think of as the Antarctic continent is not actually land. It is ice resting on compressed crust. Remove the ice and the shape of the continent would change completely. Coastlines would shift, valleys would flood, islands would emerge. The map itself would need to be redrawn, but we cannot remove the ice. And even if we could, we would not know what we were looking at. The land beneath has been sealed away for so long that it belongs to a different world, a world with different climates, different ecosystems, and possibly different inhabitants. This creates a unique problem for anyone trying to understand Antarctica's past. We are attempting to study a continent we cannot see. We are drawing conclusions about landscapes we cannot reach. We are interpreting data from instruments that penetrate ice but cannot provide images. It is like trying to read a book through a frosted window, possible in theory, but distorted in practice. Satellite imagery helps, but only to a point. Satellites can detect surface features and measure ice thickness. They can identify temperature variations and track movement, but they cannot see through kilometers of ice to the bedrock below. For that, researchers rely on radar and seismic surveys, technologies that send pulses into the ice and measure the reflections that return. These reflections reveal a hidden world, a world of mountains, valleys, and plains buried beneath the surface, a world that looks nothing like the flat white expanse visible from above. Some of the mountains beneath the ice are taller than those in the Alps. Some of the valleys are deeper than the Grand Canyon. There are rifts, basins, and plateaus that rival any geological features found on other continents. But radar data is not the same as observation. It provides outlines, not details. It shows shapes, not textures. It suggests features, but it cannot confirm them. The land beneath Antarctica remains fundamentally unknown, visible only as shadows in data, interpreted through models that rely on assumptions about rock density, ice behavior, and signal propagation. This lack of direct knowledge creates an opening for mystery. If we cannot see what lies beneath the ice, how can we be certain it contains only natural formations? How can we rule out the possibility of something artificial? How can we dismiss the idea that structures, artifacts, or remnants of earlier worlds might be hidden in the darkness? The answer is that we cannot. Not with certainty. We can make educated guesses based on probability. We can apply Occam's razor and assume the simplest explanation is correct, but we cannot know. This is what makes Antarctica so unique. It is not a place where mysteries are solved. It is a place where mysteries are protected. The ice does not simply hide the past. It preserves it, locks it away, and ensures that only fragments ever surface. Even modern expeditions with advanced technology can explore only a tiny fraction of the continent. Research stations are confined to coastal areas or a few accessible inland sites. This inaccessibility creates a paradox. Antarctica is one of the most studied places on Earth, yet it is also one of the least known. We have mapped its ice surface with extraordinary precision. We have drilled cores that reveal climate data spanning hundreds of thousands of years. We have detected subglacial lakes and ancient river systems, but we have not seen the land itself. We have not walked its hidden valleys or examined its buried peaks. We have not confirmed what the radar suggests or what the ice conceals. In this sense, the Black Pyramids are not an anomaly. They are a symptom of a larger truth, that Antarctica holds far more than we can currently access, and that our understanding of the continent is built on inference rather than observation. If structures exist beneath the ice, they would be perfectly preserved, protected from erosion, weathering, and decay, sealed in conditions that prevent biological degradation, frozen in time as completely as the ancient ice itself. And if those structures were placed there during a period when the continent was habitable, they might be millions of years old, far older than any civilization we have ever documented, waiting in silence for the ice to recede, or for technology to finally penetrate the layers that keep them hidden. Antarctica does not refuse to be known out of malice. It refuses because that is its nature. It is a continent built for concealment, a place where the planet stores what it does not want disturbed. The human brain is a pattern recognition machine. It evolved to detect threats, identify food sources, and interpret social cues. It finds faces in clouds, animals in constellations, and meaning in randomness. This ability kept our ancestors alive. It also makes us vulnerable to seeing things that aren't there. When people look at the Black Pyramids of Antarctica, this tension becomes unavoidable. Are we seeing evidence of something extraordinary, or are we seeing what our minds are programmed to find? Psychologists call this pareidolia, the tendency to perceive familiar patterns in ambiguous stimuli. It explains why we see faces on Mars, figures in tree bark, and shapes in ink blots. The phenomenon is so common that it is considered a normal function of human perception. But calling something pareidolia does not make it go away. It simply names the experience without explaining what triggers it. The pyramids trigger something deeper than random pattern recognition. They trigger architectural recognition. The shape of a pyramid is not arbitrary. It is one of the most stable geometric forms. It distributes weight efficiently. It resists collapse. It has been used by civilizations across the world for thousands of years, not because of shared contact, but because the form works. When we see a triangular structure rising from the snow, our minds do not simply see a triangle, they see architecture, they see intention, they see design. This reaction is not irrational. It is based on experience. We know what pyramids are, we know what they represent. And when we encounter a shape that resembles them in a place where they should not exist, the mind struggles to reconcile the contradiction. This is where the debate becomes psychological as much as geological. Skeptics argue that we are projecting familiarity onto natural formations. They say the pyramids look artificial only because we want them to, that our expectations shape our perceptions, that the similarity to known structures is coincidental. But this argument assumes that recognition is always a mistake. What if recognition is sometimes accurate? What if the mind identifies patterns because patterns exist? What if the shape we see is not a misinterpretation, but an echo of something real? The pyramid form appears across human history with strange consistency. In Egypt, the Great Pyramid of Giza rises from the desert with mathematical precision. In Mesoamerica, the Pyramid of the Sun dominates Teotihuacan. In Sudan, more pyramids exist than in Egypt, though they receive far less attention. In China, massive burial mounds take pyramidal forms. In Europe, ancient structures like Silbury Hill suggest pyramid-building traditions predating recorded history. These structures were not built by connected civilizations. They arose independently, separated by oceans and millennia, yet they share the same basic geometry, the same orientation principles, the same symbolic associations with the cosmos, the afterlife, and divine power. Mainstream archaeology explains this pattern through convergent evolution. Humans, when faced with similar challenges, develop similar solutions. The pyramid shape offers structural stability. It requires no advanced engineering. It emerges naturally when you want to build something tall and lasting. But this explanation does not account for the symbolic consistency. Pyramids are not just stable structures. They are sacred structures. They represent mountains, gateways, cosmic order. They align with stars, solstices, and cardinal directions. They embody knowledge of geometry, astronomy, and landscape architecture that seems too sophisticated for the societies that supposedly built them without contact or shared knowledge. What if the pyramid form is not a solution, but a memory? A shape passed down through cultures that inherited fragments of older knowledge. A form that predates the civilizations we study and survives as an instinct embedded in human consciousness. This possibility makes the Antarctic pyramids far more unsettling. If the shape is universal because it is ancient, then finding it in Antarctica suggests the continent may have been part of the world where that knowledge originated. Not a coincidence, not a natural formation, but a remnant. The psychological resistance to this idea is strong. Accepting it would require accepting that human history is far longer and far more complex than we have been taught. It would mean that civilizations rose and fell before our oldest records. That knowledge was lost and partially recovered. That the story we tell about our origins is incomplete. Most people are not ready to accept that. It is easier to dismiss the pyramids as natural formations, misinterpreted by overactive imaginations. It is safer to rely on pareidolia as an explanation. But safety is not the same as truth. There is another psychological factor at play, the discomfort of not knowing. Humans prefer certainty. We prefer explanations that close questions rather than open them. The Black Pyramids do the opposite. They open questions that cannot be easily closed. They introduce doubt where there should be none. They suggest possibilities that most of us have been trained to reject. This discomfort manifests as skepticism, but it is not skepticism based on evidence. It is skepticism based on worldview, on the belief that history is settled, that the timeline is accurate, that the past is understood. The pyramids challenge that belief not with proof, but with presence. They sit in satellite images, silent and unexplained, refusing to disappear. What if the real question is not whether the pyramids are natural or artificial, but whether we are psychologically capable of accepting the implications if they turn out to be artificial? What if the resistance comes not from the evidence, but from the consequences of belief? Before we can answer that, we must examine another piece of the puzzle. A piece that predates satellites, photography, and modern exploration. A piece that suggests someone long ago knew things about Antarctica that should have been impossible to know. In 1929, a group of scholars examining old documents in the Topkapi Palace in Istanbul discovered something extraordinary. A map drawn on gazelle skin, dated to 1513, created by an Ottoman admiral named Piri Reis. The map showed the Atlantic Ocean, the coastlines of Europe, Africa, and South America, and something else, something that should not have been there. At the southern edge of the map, extending from the bottom of South America, was a landmass, a coastline drawn with detail and precision, a shape that resembled Antarctica. Not Antarctica as it appears today, covered in ice, but Antarctica as it might have looked if someone had mapped its coastline before the ice covered it. At first, historians dismissed the southern landmass as artistic license. Medieval and Renaissance maps often included imaginary continents, speculative lands drawn to balance the composition or reflect theoretical geography. The southern land on the Piri Reis map was assumed to be one of these inventions. But then researchers began comparing the map's southern coastline to modern data. They noticed something disturbing. The shape matched, not perfectly, but closely enough to be unsettling. The curves, the bays, the proportions all resembled the coastline of Queen Maud Land, a region of Antarctica that would not be officially discovered until 1820, more than 300 years after the map was drawn. The match was not exact. Maps from the 16th century never are. But it was close enough to raise questions. How could Piri Reis have drawn a coastline that resembled a continent unknown to his world? How could the proportions be so accurate if the landmass was imaginary? Piri Reis himself provided a clue. In the margins of the map, he wrote that he had compiled it from older sources. Some of these sources, he claimed, dated back to antiquity. He did not specify who created the original maps or when, only that he trusted their accuracy and used them as guides. This admission transforms the mystery. If Piri Reis was copying older maps, then someone before him had access to geographical knowledge that should not have existed. Someone who had mapped the southern continent before it was covered in ice. Someone who possessed navigational technology and cartographic skill advanced enough to chart coastlines with precision. Mainstream historians reject this interpretation. They argue that the southern landmass on the Piri Reis map is simply an extension of South America. that the resemblance to Antarctica is coincidental, that no one in ancient times could have known the continent existed, let alone mapped it. But the argument feels strained. The shape is too specific, the details too consistent. And the fact that Piri Reis mentions using ancient sources suggests he was working from information that predated his era by centuries or millennia. What if the map is evidence of a forgotten age? An age when Antarctica was accessible and inhabited, an age when civilizations possessed knowledge of the world that would later be lost. This possibility is not as far-fetched as it sounds. We know that advanced knowledge can disappear. The Library of Alexandria burned, the Maya codices were destroyed, entire civilizations vanished, taking their records with them. What survives is often fragmented, misunderstood, or dismissed as myth. The Piri Reis map might be one of those fragments, a piece of cartographic knowledge that survived through copies, passing from one culture to another until it reached the hands of an Ottoman admiral who had no idea what he was drawing. If the map truly shows Antarctica before the ice, then several things must be true. First, someone mapped the continent millions of years ago during a period when the coastline was exposed. Second, that knowledge survived long enough to be copied and passed down through generations. Third, the civilization that created the original maps was capable of exploration, navigation, and record-keeping on a scale we associate with modern societies. Each of these implications is difficult to accept, but together they form a coherent hypothesis. A hypothesis that suggests human history, or the history of intelligent life on Earth, is far older than we believe. The map does not prove the Black Pyramids are artificial, but it complicates the assumption that they must be natural. If ancient maps contain knowledge that should not exist, then perhaps ancient structures exist in places we assume were uninhabitable. The Piri Reis map stands as a quiet challenge to the accepted timeline. It does not demand belief, it demands attention. It suggests that the past is not a closed book but an open question, and it reminds us that sometimes the most important discoveries are not made through excavation or exploration, but through re-examination of what has been in front of us all along. What if the map and the pyramids are connected? What if they are both remnants of the same lost world? What if Antarctica holds not just geological secrets, but historical ones? Secrets that, if uncovered, would force us to rewrite everything we think we know about the rise of civilization. Before we can explore that possibility, we must first understand what Antarctica was before the ice came. Because if the continent was once warm, once alive, once capable of supporting complex life, then the idea of ancient structures becomes less impossible and more inevitable. There is a version of Antarctica that exists only in scientific reconstructions and ice core data. A version so different from the frozen desert we know that it feels like a description of another planet. In this version, the continent is green, rivers carve through valleys, forests spread across lowlands. The air is warm enough for rain instead of snow, and life, abundant and diverse, fills every available niche. This is not speculation, it is established fact. Antarctica was once a thriving ecosystem. The evidence exists in layers of sediment, fossilized pollen, and chemical signatures trapped in ancient ice. Researchers have found remnants of temperate forests that flourished near the South Pole around 90 million years ago. Trees that survived months of polar darkness, plants that adapted to extreme seasonal variation, ecosystems that persisted in conditions we would consider impossible. But this was not the only warm period. Antarctica has experienced multiple climatic shifts. Periods of ice followed by periods of warmth, cycles that transformed the continent repeatedly over millions of years. Each time the climate changed, the landscape changed with it. Glaciers advanced and retreated, coastlines shifted, entire regions flooded or dried out depending on global sea levels and temperature fluctuations. What makes this history so significant is the implication it carries. If Antarctica was habitable multiple times in the past, then the possibility of human presence or the presence of intelligent life cannot be dismissed based on climate alone. The question shifts from could anyone have lived there to when could they have lived there and what might they have left behind. The most recent warm period in Antarctica ended around 34 million years ago when the ice sheet began its final advance. But before that, there were earlier warm periods, some lasting millions of years, some brief and violent. The transitions between warm and cold were not always gradual. Ice core data reveals abrupt shifts, temperature changes that occurred within decades rather than millennia. These rapid transitions would have been catastrophic for any life on the continent. Forests would have died, rivers would have frozen, coastlines would have disappeared beneath advancing glaciers. Anything living there would have been forced to migrate, adapt, or perish. But what if something survived, not biological life, but remnants? Structures built during a warm period and sealed beneath the ice when the climate turned, protected by the same cold that destroyed the ecosystems around them. This is the scenario that makes the Black Pyramids plausible. If Antarctica was once warm enough to support complex life, it was warm enough to support intelligent life. And if intelligent life existed there, it might have built. Not with modern technology, but with the methods available during that era. Stone structures, megalithic monuments, geometric forms designed to withstand time. The ice would have preserved them, not perfectly, but sufficiently. Stone does not decay, it does not rot, it endures. If a pyramid was built in Antarctica during a warm period and then covered by ice, it would look today much as it did when it was built. Sharp edges, clean angles, symmetry intact. The geological record supports this preservation hypothesis. Subglacial mountains remain remarkably pristine despite being buried for millions of years. The ice acts as a protective barrier, preventing erosion and weathering. Anything beneath it exists in a kind of stasis, unchanged by the passage of time. But mainstream science resists this interpretation. Not because the evidence contradicts it, but because accepting it would require accepting that intelligent life existed in Antarctica long before recorded history, and that idea conflicts with the established timeline of human evolution. Anatomically, modern humans appeared around 300,000 years ago. Civilizations as we define them emerged around 6,000 years ago. Antarctica's last warm period ended 34 million years ago. The timelines do not align, unless the timeline is wrong, or unless the life that built in Antarctica was not human. This is where the discussion becomes uncomfortable, not because it ventures into pseudoscience, but because it forces us to consider possibilities that have no place in textbooks. What if intelligent life appeared on Earth long before humans? What if earlier species developed technology, culture, and architecture? What if they left traces that we have not recognized because we assume intelligence is unique to our species? The fossil record contains gaps, transitions that seem abrupt, species that appear suddenly without clear evolutionary precursors. Some of these gaps may be due to incomplete preservation. Others may reflect events we do not fully understand. And a few, just a few, might indicate that the story of life on Earth is more complex than the linear progression we imagine. Antarctica's ancient forests prove one thing conclusively: the continent was not always hostile. It supported ecosystems as rich as those found anywhere else, and if ecosystems thrived, then the conditions existed for intelligence to emerge, adapt, and build. The pyramids, if they are artificial, would not belong to the Antarctica we know. They would belong to a different world. A world of green valleys and flowing rivers, a world where the sun rose and set over landscapes now buried beneath ice. A world that existed, thrived, and vanished, leaving behind only fragments for us to misinterpret millions of years later. This is not proof, it is context. Context that makes the impossible seem merely improbable. And in a place as strange as Antarctica, improbable begins to feel almost inevitable. In 2013, a team of researchers analyzing radar data from Antarctica made a discovery that redefined what lay beneath the ice. They found a mountain range, not a small cluster of peaks, but an entire range stretching more than 1,200 kilometers across the interior of the continent. A range comparable in size to the European Alps, completely hidden beneath ice up to 4 kilometers thick. These are the Gamburtsev Mountains, and they should not exist. Mountains erode. Over millions of years, wind, water, and ice wear them down into rounded hills and flat plains. The older a mountain range, the more worn it becomes. The Gamburtsev Mountains are ancient, possibly over 1 billion years old. By all geological logic, they should have been ground into bedrock long ago. Instead, they remain sharp. Their peaks rise dramatically, their valleys cut deep. Their ridges stand crisp and defined. It is as though they were frozen in their youth, preserved at a moment when they should have already been eroding.